I'm Moritz Wiese, and I present work with Panos Papadimitratos about frequency hopping. We tested its, or we analyzed its resilience against jammers using information theory. Frequency hopping is popular to protect communication against jamming, but we show that information from the information theoretic point of view, it doesn't really improve the resilience, given the right circumstances.
Okay, hello. The title of our poster is Adaptive Pilot Clustering in Heterogeneous Massive MIME Networks. This is joint work by me, Rami Mshaurab, and Emil Björnsson and Matt Spankston. So we consider a multi-cellular network where the base stations use a large number of antennas, and there are many users in each cell. And this technology has the advantage of delivering high spectral efficiency by serving many users at the same time. But this technology needs channel state information. Sorry? It's gone? What do you mean? Okay, so we need channel state information at the base stations, and this is done in TDD systems by the use of pilot sequences. But when we serve many users, then we need a lot of these pilots, but these are naturally limited. And the problem is that how to allocate the pilot sequences among the cells in order to get good or accurate channel state information at of the users. And we design a distributed and efficient algorithm for this problem.
Hello, I'm Xiaolin, and from this work, we investigate the accuracy of a simplified interference model for the millimeter wave communication, and based on two assumptions. The first is impenetrable obstacle, and the second assumption is no set lobe gain, and the accuracy performance of this simplified interference model can be found at the poster session. Thank you.
Hello, my name is Sebastian. My poster is about wireless communication with very low delay. So in industrial automation, you would have delays of just a few milliseconds. Now, this is difficult to analyze from the information theoretic point of view. If we do that, then we have to include some new results about imperfect CSI and finite block length. And there are some very smart guys who did some results, but we have to extend these results to the higher layers in order to find the delay. And we find that the results, are interesting.
My poster is on plan synthesis for multi-agent systems that first support specifications of high-level complex collaborative tasks. Second, the method yields correct by design plans. And third, it's efficient, meaning that it's not centralized.
I'm doing research on coordinating track platooning. Track platooning is a very exciting new technology that can help to reduce fuel consumption and improve safety. I figure out which tracks should platoon where and when. So if you want to learn more about this, come to my poster and talk to me.
Hello, I'm Mane. I'm looking at optimal speed trajectories for a heavy-duty truck, and I'm using the Pontryagin maximum principle to do that, and it's a very simple model so far with including road elevation and restrictions on the maximum forces, and also I have some speed restrictions, maximum minimum speed, where I try to analyze real data collected from live operation in order to set these restrictions.
Hello, in my poster I will tell you about the remaining security, privacy, and operational challenges in order to deploy identity and credential management for the upcoming vehicular communication systems.
Hello, my name is Hong Yujin. In this poster, I will present a decentralized privacy preserving scheme for location-based services. In such open system, users are exposed to external and internal adversaries. So this is what we address in this poster. We leverage public key infrastructure to hold accountability of user actions in the system in a privacy-preserving manner. Thanks.
Hello, everyone. My name is Patricio Valenzuela. I'm a PhD student at the Department of Automatic Control at KTH. Today I will present a work on how to account for the uncertainty when identifying dynamical models that play a role, and we will use risk theoretical tools to measure that. And please, you're welcome to visit my poster to know more about this work.
Hello, my name is Mohammed Abdel Mauti, and I'm presenting today a joint work with my supervisor, Wakani Al-Marshan. We're both from the Automatic Control Department of KTH, and we're looking at the problem of identifying a Wiener stochastic model. And the basic difficulty here is that you don't measure a signal ZK, you only measure UK and ZK. So if you try to estimate this with maximum likelihood, the likelihood function involves a multi-integral. If you want to know a solution, please come talk to me. Thanks.
Hey, so the next topic is on event-based control and estimation in sensor networks. And the main feature of event-triggered systems compared with time-triggered ones is resource efficiency, as one only processes data when really necessary. And in my poster, you will see, I will show how to design these triggering rules and guarantee that only important information is sent over the network. Thanks.
So hello everyone. So this is collaborative research, about this characterizing the semi-definite weighted Laplacians via these effective resistance matrices. So the motivation is actually coming from a very broad, spectrum of applications, including like robustness in cooperative control, including resilience in power systems. So the questions we answer are threefold. So what is the graph theoretical condition for a weighted Laplacian to be positive semi-definite? So how to characterize a set of negative weights that maintain the semi-definite of weighted Laplacian? And in terms of circuit theory, when does a multiple network with active components still remain passive? So if you want to know the details, please feel free to talk to me during the poster session. Thanks.
Hi everyone, my name is Axel. I'm a PhD student in applied mathematics at KTH, and we're looking at multidimensional moment problems, which is basically given ck and some basis function alpha k, you want to reconstruct a non-negative measure d mu. Applications of this are within system identification, and we also have proof of concept simulations for image compression and for reconstruction of images using CT data.
So I am Emil Eriksson, and if you come talk to me up in this corner over here, I will tell you how you can use very cheap devices to create video surveillance systems, complete with feature extraction for detecting traffic or pedestrian or indeed cats, and how you can overcome the computational limitations of these devices.
I'm Hanwei. Our group's work is joint geometric verification and ranking using multi-view vocabulary trees for mobile 3D visual search. The visual search generally considers two aspects of similarity, the visual appearance similarity and the 3D geometry similarity. In this work, we try to explore solutions to combine both visual appearance and the 3D geometry similarity for the ranking of the search results. Thanks.
Hello, I'm Du. I'm working on video compression, and in this work we hope to find a good energy compaction that compacts the information or the energy to the first frame, so it can give efficient coding performance. And in our work, we model the motion trajectories as graphs and use these graphs to construct motion adaptive transforms.
Mm-hmm. Hello, my name is Mailton. I've been working on full duplex communications, which is envisioned as a potential candidate for future cellular networks, such as 5G. And here we see that it's envisioned that we can double the spectral efficiency, but is that possible with distributed optimization? So if you're interested, just drop by at my poster and we discuss. Thank you.
My name is Valentino Pacivici. This is not my poster. Yes, thanks. And, but I know the authors. This is a joint work between Slažana Jošilo and Georgi Dan. It's about computation offloading for mobile cloud computing. And mobile edge computing is a promising solution for computation under strict delay requirements. And it's characterized by computing resources, a high bandwidth and low latency since it's close to the network edge, and by the real-time access to radio network information. And what they look at is offloading computation to a mobile cloud. And the problem they address is how to utilize the mobile edge computing efficiently. They look at the competition of resources, computing resources, and bandwidth, and also at the coordination between nodes.
Hello, I'm Pedro. I'm a PhD student. Our project focuses on the resilient management in smart grid. First, we virtualize control functions into the software instances and put them into the mobile edge cloud. By doing this, we're able to do some joint optimization for resilience. Our research includes this, algorithms of VCF placement and reconfiguration. Welcome to our poster. Thank you.
Since the increasing demand for video content from users, is increased like requirements on the side of the network operators. It has also introduced some bottlenecks in the mobile backhaul capacity of the networks. So in this scenario, in-network caching could be a solution as it reduces the bandwidth requirement and it improves the quality of experience of the users, the operator subscribers. In-network caching is enabled by the SDN and by the mobile edge clouds in the 5G. And our objective is to develop efficient in-network caching strategies through designing algorithms that can work even if the knowledge, the information about the content popularity is not available at a single place in the network.